KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Welcome to Homework Hotline. My name is Amy Taylor and I teach 8th grade math, Integrated 1 and Integrated 2 to Sunnybrae Middle School students through Zoom.
And my name is Pam Halstead. I taught science at Fortuna High School.
Welcome to the show, and what's cool is if you watched me on KEET TV Tuesday or you saw us on Homework Hotline TV on the YouTube and it says scientific notation, I taught that on Tuesday and it perfectly lines in with Science Integrated for Pam today.
It so does, and I'm so happy. And that wasn't even planned, but you know, it's just how it works sometimes.
We end up doing things like that.
It's really good.
That's why they're so integrated.
Yes, that's right. We don't even know it, but they're integrated. So the title of today's show is Tides, Their Causes and Effects. And they affect us literally here every day because we live very close to a very large body of water called the Pacific Ocean.
Huge.
Huge body of water. So we're
Which
going
is
to take
why we have so many immigrants.
Yes.
I didn't even talk about that, but that's another like social studies because we're right by the ocean and then it connects to other land masses.
Yes,
you know,
yes, that's right.
And
People
trade and etc.
True, very true. So first I'm going to ask you a question which I sort of already gave away, Amy, but so this is all going to be an interactive PowerPoint that we have going on.
Okay.
So where do we go to see the tides? And I have 3 answers for you. One is downtown Eureka. The other is Arcata Marsh. Or your third option is Willow Creek.
Downtown Eureka, though, you could go to the waterfront.
Well,
but you won't see a King
yeah,
Tide. So
you
I'll
are
say
right.
Arcata.
You are so right. Yeah, that was what I was going for, but you're right. I mean, downtown Eureka because it's right on the water.
Yes.
Yes.
But Willow Creek
Good
is
point.
very inland.
Yes, very inland. So
Arcata Marsh, though, can't you get things up the slough?
This is the Arcata Marsh.
Oh, it is?
This is,
Okay.
right? This picture right here is.
Oh, perfect.
Yeah, this is on.
You mean downtown Eureka, like
Yes.
buildings?
Like the buildings place, yeah. So if you were like next to the Catholic Church, the big one, you know, or like F Street or whatever, in the mid, just further away from the water.
Further from the water.
Right.
We do live in Humboldt County, which has a lot of water.
Yes, it's true. This is from, the picture is from H Street in Arcata. So.
Oh, cool.
Yeah, during high tide, very high tide. So then we're gonna, here's another question. The question is, which force has the greatest effect on tides? And as far as physics goes, in terms of forces, a force is a push or a pull on any object. That's what the very basic thing of a force.
Isn't it things with like the moon?
Well, let's find out. Let's find out. You have some choices.
Okay.
You have gravitational as one force, then you have electrical as another force, and your third force is magnetic.
These sound like superhero things. I would say gravitational.
Well, that is very good. You have it. Okay, so if we look at gravitational, gravitation is the force of attraction acting between any 2 bodies. And you just said something about the moon, which is great. We'll definitely be getting to that. And gravity is the force that holds you like onto this planet, basically. So the force that has the greatest effect on tides because it's pulling on the water at different times, which we'll take a look at how it actually does that. Yeah. So you got it, gravitational.
And that is different here than you would say on the moon. Like different places have different gravitational pulls. And this is just affecting Earth's gravitational pull.
Yes,
right?
It is. It's a gravitational pull between Earth and something else, some other body, whether the sun or the moon or the Earth. We have planets. We have Mars, which is a close, and Venus. So anyway,
But you wouldn't have the same thing we're talking about today, say on another planet, if they had different gravitational pulls, like or a different moon.
Gravity. That's
gravity.
The thing.
Oh, it's the pull.
So there is a difference between gravity and gravitational pull. Okay, so no problem. Gravity causes gravitational pull.
There we go.
Because if you were a body and I was a body, we both had different gravities, then we would be affecting each other gravitationally.
Differently.
Yes. Okay. Very good.
Okay.
All right. So then we have another question here.
It's good.
Yes, it's very good.
It's
very good. So which astronomical objects control tides on Earth? So you're going to have some choices here.
Okay.
You have the sun and Venus. You have Venus and Mars, and you have the moon and the sun.
Control tides on Earth.
The tides.
There's no moon and except for sun. I'll go moon and sun.
Moon and sun, good for you. Because you definitely
I was like,
got
well,
the moon
Mars
and
is
sun.
next to us and
I
the
know.
moon's close, so I figured if there was moon and Mars, I might have thought differently.
I know.
But there's
Mars is not a super big planet, and neither is Venus. Venus is about our size, the size of our planet. But it's quite a bit away. It's quite a bit further away.
Okay.
So if you look, then here's a little diagram that shows the Earth in the center of the moon and the sun, and both of them have an effect on the tides, basically, which it means they're pulling. Now let's just take a look right here at two things that I brought from home, which are very basic. But this is a rock, which is representing land mass.
Okay.
Now we understand land can be soil, it can be eroded rock, so it can be more cushiony than this, but that's going to be. And this is ocean water.
Okay.
Okay. So if I'm pulling on this, because what happens is gravity is from another planet is pulling on our planet. Which would it have more of an effect on? So it's pulling on the land, which by the way does pull the land some. We're pulling on the land. We're trying to get the land to change shape, but then we're pulling on the water, trying to get the water to change shape.
much easier water.
Oh my gosh, feel it. Feel the water.
Versus like
This is a liquid versus a solid, yeah.
and this is attached to more.
It is.
And this probably feels like this no matter what, because it's water.
Right, and it's able to move because the molecules are not as close together as the molecules of this. So the atoms and molecules of this are much tighter together to make a solid.
But the
versus a
force
liquid.
that this does could push this more than just the gravitational would push this. Like
Yes.
the water, the gravitational pull pulling this could affect this.
It could.
Because it's pushed, the water is pushing on this a lot.
It could cause like erosion and stuff.
That's what I was thinking.
Yes,
Yeah,
it can.
yes, yes.
Right, so it can cause this to.
But it's easier to move this.
Definitely easier to move that. Absolutely, that was good. Okay, cool. So let's move on. All right, so here, what two variables, a common term in math, are used to calculate the gravitational force? And I'm going to give you a big hint here, okay? So there is an equation for us. All right, so we've got two masses and two
mass
bodies.
1 times mass 2.
Right, so we've got G,
I'm
which is
R is radius squared?
yeah. Look at R on the picture. Okay, look at mass 1 and then mass 2, and it is the distance between the centers.
It is. So it's kind of like, well, radius is just would be of the circle, but but that makes sense. It's coming from the center where a radius would come if it was a circle.
Right.
But it's just R. So it's the distance between the center of mass 1 to the center of mass 2.
You got it. So then, and G, just so you know, is a gravitational constant. So don't worry, that will.
I actually did a math problem fairly recently on a unit activity. We're using Admentum that applied this.
Oh my gosh, that's so
super
cool.
funny because I'm like, I might be better because of that unit activity.
That's super great. That's so cool. And then, so you know about the G. Doesn't,
sort of.
Well, no, don't worry about what it means. I mean, what I mean is what the number is. You know, it's like times 10 to the negative 11 or something. But it's just that it's there all the time. It never changes. So the only things really being affected are the mass and the distance.
Okay.
Okay. So if I'm going to go to the next thing here, and so the two variables that are used to calculate besides the gravitational constant are the mass and the distance.
Okay. Which is basically what we said.
Right.
Yes.
So okay, cool. Now let's continue.
That's so funny. I mean, it's cool that I did that.
It is. Okay, so if mass had the greatest effect on tides, who wins? Okay, so just mass, pure mass. If it was mass, and we're still talking about the moon and the sun now.
Yes.
Okay, so if mass had the greatest effect on the tides, let's check out the sun.
Oh,
yeah.
Oh, wait, we're looking at numbers. Okay, I thought we were just guessing.
Okay, so that's.
Oh, we did this yesterday.
Yes,
or 2 days ago.
We did. So here it is, 2.2 times 10 to the 27 tons.
The decimal place 27 times with 26 zeros. You do not want to write that in standard form.
And if you want to figure it out in pounds, there's 2,000 pounds in a ton.
Oh, so it times it by 2,000, which is 3 more place values and a 2.
It's crazy. Okay, so let's keep going. And I was sort of surprised by this. Here's the moon's mass. So it is 7.3 times 10 to the 19.
Wait, is it just more dense?
It
must
yes.
be. More,
yes.
less gases.
Okay, here's the thing. The sun is a star. So the sun is a gas ball of hydrogen and helium.
Okay.
And so the moon is a solid structure, and there's a great thing to show how solids are more dense or more heavy.
Yeah, because that's only times 10 to the 8th, which is like 10,000 tons, which tens of thousands of tons is not that much when you think of sun versus moon.
Right.
But due to all the gases, it's not, that don't weigh as much, then it is fairly close in just straight mass.
Yes.
That's
yes,
crazy.
it's fairly close, and yet let's think about this. It's scientific notation, and to 19 to 27 is...
Oh, that's what I'm saying, tens of thousands of tons.
Yes.
But you're thinking like planets, moons, suns. You would think that's a lot for like lifting something, but I'm thinking if I think of giant things. So it is a lot, but not as a lot as you would think for sun to moon.
Correct.
Because
the sun is so much massively bigger. Oh, we're going to take an actually look right here, right there.
Yeah, because 10 to the 8th is, so 10 to the 6th, oh, million, sorry. It's
million.
Yeah.
An eighth, so it's even, it's almost a billion.
100 million.
Yeah, 100 million, okay.
100 million times as big in tons.
Yes.
But again, still relative because it's so huge.
Right,
it's so huge.
All right, so now we have a picture of the sun and the planets, all of them in our solar system.
Yeah, look at the sun.
This sun is dwarfing everybody else. Looks totally dwarfed compared to the sun.
Yeah, it's crazy.
Yeah, it is crazy. So the teeny weeny little tiny moon still has a lot of mass, but then it's a solid. Even the sun's a giant ball of fire. Yeah, it's crazy. All right, so who wins? You said it, the sun, and you're right. So does the sun have a greater effect on the tides? And we're going to find out whether or not. Hold on, because now let's ask the question, if distance from Earth had the greatest effect on tides, who wins? Let's go distance.
And I did distance on Tuesday from Jupiter and Saturn.
Yes, you did.
And now we're doing distance.
Now we're doing
exciting.
sun. Yes, awesome.
These are much closer than Jupiter and Saturn.
Yes, it's 93 million miles.
Well, the sun isn't, but I mean the moon must be way closer.
Oh yeah, definitely. So here we go with 9.3 times, because as you said.
Tens of millions.
Yes. Okay.
90 million.
Yeah. So there you go. And then the moon distance is
10 to the 5th. Now we're in thousands. Now we're in 100,000.
Yes.
200,000.
So
240,000.
Definitely closer. Now I think the next thing on this slide is pretty darn tiny, but Amy and I have a closer look at it, so we're going to take a look at it right now. It is a graphic. So we're going to take a look at that graphic and see why and how the distance has a bigger effect, and a significantly bigger effect than mass. Okay, so in this tiny little thing, if we can get it up close up, or at least a little closer. So we have here, they do it in kilometers. Let me just show you something here too. A kilometer, 1 mile is equal to 1.6 kilometers, just in your mind. You have to memorize that, but okay, so now we look at the moon and the Earth. So we have the distance, how close the Earth and the moon are compared to the Earth and the sun. And then, so the thing is, we're talking gravitational force, right? Okay, so gravitationally, the sun wins hands down over the moon because it's so massive.
Yes.
But the tide generating force has a huge thing to do with distance. Remember, it was r squared at the bottom, distance squared. Look at this, it's distance cubed.
Oh.
So now we take the sun's mass and divide by the sun's distance to Earth cubed. That's it multiplied by 3. I mean, 3 times itself. Then the sun has 27 million times more mass than the moon, and it's 390 times further away. So if we actually do the calculation, we have 27 million is the times more mass on the top, and we have 59 million, which is the distance cubed. Then it's 0.46 or 46% of the tide generating force of the moon. Does that make sense?
Yes.
Okay. Well, this is
because you're dividing by you're taking numbers and you're dividing by smaller numbers.
Yes.
So if you divide by smaller numbers, it's like you're multiplying by bigger numbers.
Right.
Because you multiply by the reciprocal.
Right. So
or in general, you're not.
So determining gravitational means that the sun's mass is going to take over because the radius squared is a lot less than the radius cubed.
Yes.
Okay. Well, and there you have it, everyone. So that's why when we look at tides, we more care about what phase is the moon in. So we wonder what phase is the moon in, because this is important to looking at how tides work. And so let's take a look at that. Let's first ask the question, how many days does it take the moon to orbit the Earth? And we have a graphic of the moon as it orbits the Earth. So it's going around. So it starts at new moon, which is labeled A, and then it goes all the way, and then it goes up there to gets bigger. Waxing gets bigger, crescent. Then first quarter, which is a half moon basically. Then waxing gibbous, which is basically like the moon's the shape of a football. Then we have the full moon, and then we go back around to the new moon. So how long does that take? Amy, which time period is closest? A day, a week, a month?
Day, a week, a month. I'm going to say month.
You got it. It's 27.3 days. And this is why we have things like the
that
leap year.
often. I'm like,
Yeah. No, you don't, right? And it's not perfectly a month. So
Yeah.
like when you're looking at the calendar, you can't go, well, always the fourth Friday is the full moon. You know, it's not.
Yeah.
So we're a little bit off of that, yeah.
Yes.
But anyway, that's how long it
close
takes.
to February, which
Yes.
is the month we're close to.
Right. Yes, that's right. And February's the weird one, but it has a little shorter.
But it's at least close to that.
We manipulate the calendar so that it works for us, basically. Yeah, the days, you know, it's not perfect, but it does work. So that means is it 4 years we have to add?
Yes, because it's 365 and a fourth date.
Yes.
365, yes, and a fourth.
And a quarter, right.
So then every 4 years, yes.
Yeah, okay, nice.
Which
All right.
happened in 2020.
Yes. Awesome. All right, so let's take a look at why so we just had tides, and Amy was mentioning Tuesday, but Monday and Tuesday were what's known as king tides, which are super high tides, which we will talk about.
But can it come after like Saturday? It seemed like we went out to the beach and it was like there was no water, like the place that we usually go.
That's the low tide.
But does it happen before, like, or does it, not necessarily? It could be low tide, high tide. Like the king, like
no,
it was
it's great.
super low
Here,
on
wait.
Saturday.
Let me just make sure I know what we're talking about. Yes, because the next slide is all about what you're just saying. Now, totally.
It was just weird because it was like you could walk across where me and the kids have like swam before
super crazy
in the Coast Guard
low.
area.
That's right.
I've never seen it that way.
As high and low.
Okay.
Okay, so we'll talk about that.
Okay.
All right.
Because you said Monday, Tuesday, so I was like Saturday that happened. So,
yes.
Okay.
Yeah, and and it happens for several days. Like the new moon. Okay, so let's look at the diagram.
Okay.
So the spring tide are the highest tides basically, and they happen during the new moon and the full moon. Yes, and so it's that the new moon is pretty obvious because you got the sun and the moon acting on together to pull.
Yes.
Okay.
Oh, lunar tide, solar tide. Oh,
and the full moon is it's when. Okay, so here, Amy. Okay. Sorry, we're going off that thing now. Amy, you're going to be the moon and I'll be the earth. Okay. So Amy and I are going to pretend we both have gravity that's attracting each other.
Okay.
And I said you were the moon, right? Did I say you're the moon?
I don't know.
Whatever I said. Okay. I'll be the earth. So I have a stronger pull. Amy's pulling on me too. She's pulling on my water, my land, and everything else. But I'm really pulling on Amy so much that when Amy tries to move, she cannot ever move away from me because she has to go around me. And as she goes around me, as she does, she doesn't go in a perfect circle.
Okay.
It's because there's rotating going on while you're moving around. It's kind of complicated.
Is that the ellipse?
An ellipse.
Okay.
So there's times when you're closer to me, and there's times when you're further away from me.
Okay.
So during the full moon, you're closer to me. It's called perigee. And when you're further away from me, that's apogee.
Okay.
So anyway, and so during the new moon, it's further away, but the sun is acting too.
Okay.
So there's a double thing. So full moon, closer to me.
Okay.
New moon, further away, but sun, you got the sun, it has your back.
Okay.
So then the neap tide, back to our diagram, the neap tide is when the moon is at kind of, what would you call that? It's not perpendicular. It's like not in straight line. Is it perpendicular?
To the sun.
To the sun, kind of. It's not straight line. It's not in a straight line with the sun. When it is like this in the first quarter, third quarter,
it
looks like
it
a
looks
half moon.
perpendicular to me, but that's just because that makes a right angle.
Okay.
But I don't know if it actually is or if it's just for the picture.
No, that's fine.
Okay.
Okay, so that's when the tides aren't as high and low. The low tide and the high tide are almost the same. So they're more similar to each other. So we have more pull during the spring tide.
So this is when we have low and high, and this is when we have kind of closer medium. Okay.
Yes, closer medium, right, tides. All right, so let's continue and move on to this. This is a kind of a cool little diagram right here. And it goes, so look, I'm farther away. So this takes 24 hours to go through one. It's called tidal cycle. So here I'm high tide. Now I'm going further away as I go further away from the moon. Then I go low. Then I'm high again because I'm opposite and there's the sun.
Oh, nice.
And together, here's my high tide again. Okay, so now we'll take a look at what you just said, which is, wow, I've never seen the tide so low. Okay, so let's go to this new diagram. And there are 3 different tidal cycle possibilities. The one at the top is even, I think we're looking, there we go. The one at the top, there's the high tide and the low tide are the same no matter what. And notice over a 24-hour period, this happens twice. Same with here in Humboldt County. We have 2 tides. Like what they say about
sine waves or
yes,
sound waves or light waves. Are they just more like just even, keep happening.
Yes, even. And if it wasn't for land masses, this is the way the tides would be. But we have land masses, and that messes with the water trying to move around.
Okay.
So the type of tidal cycle that we have is the one in the center.
Okay.
So we have this is the first little lump here. I don't know if we can now, oopsie, here,
Okay,
I'm
yeah,
stepping
so you
on
can
things down
point
here.
to
Can I point to this by any chance? Okay, super. So this
nice.
this first is the high, that's the high.
Yes.
This is the high-low. This is, oh, dang me. Let me go back. No, I think I just went, no, it's fine. Here we go. Okay. When you touch it, it does funny things. This is the low-high, and this is the low-low. So what you saw, Amy, when you were there, you saw that, the low-low.
Oh.
And there's the high-high.
Oh, and then it's coming back up after,
Yes.
which is the Monday, which you were talking about.
Yes.
You had like the king tide.
Because it just keeps on going, I mean, for the 24
Okay.
hours up and down. Now, there's some tides that are crazy, like just one big high and one big low. And I think the Bay of Fundy, or something like that, it's in Europe, is something like that, where it's really, really high.
Does this vary, like go up and down for this, where it goes higher, or, I mean.
Oh, totally.
So this could be like a low, kind of this, or it could be like the same shape. But
You got
like,
it.
Yeah,
Yes,
okay.
absolutely. So the tides that we had that were the high and the king tides, they were 8.5. So this is like sea level. Well, this is maybe sea level, and that's below sea level, and that's above sea level.
Okay.
So it goes down.
That's why they're arbitrary. So you could just kind of move this up or down depending on if it's going high or low. Or like this was, because sometimes if they're not as high, you'd still have this shape, but it wouldn't be as high. But like you said, the king tides would be more like
it'd be
this.
super high, right? Yeah.
I have a question. Does it
Yes.
more like stretch, so that goes higher, lower, which they call dilations or whatever, where it's stretching, or is it more like translating where the whole thing moves up?
Whole thing goes up. The whole
Okay.
thing goes up or down. Yeah.
Okay.
Depending. So this would be during one of those neap tides. That would be the high tide,
Okay.
and then the low tide would be something like that.
Okay.
So there wouldn't be such a massive difference. That's the high
Okay.
tide, low tide.
Okay.
In fact, if we look at the next slide, the Earth's rotation and land masses cause the tidal cycle that we have.
Okay.
All right, so let's take a look at high tide. And so high tide, you guys weren't there at high tide, right? I was trying to think of things you can do during high tide. And one thing that I was noticing, like today, even we were on our walk in Arcata Bottoms, and the fields get flooded. And so shorebirds love it. These are willets. This is a picture of willets, and they're just going out there to feed on worms and things like that.
Oh.
So I'm trying to think of like what are activities in high tide that you can do.
But that's where you don't want to be getting near the water, too.
Correct. Now, if you're a good surfer and it's not the super crazy high tides we've had, like 25 feet.
Yeah.
You know, or not. It's surf, not high tides. It's surf.
Yeah.
Then you wouldn't want to be this person if you were not a good surfer. But when the surf is high, when a high tide, a lot of surfers do go out. Not necessarily during the worst time, unless it's a crazy surf contest.
Yeah.
Yeah.
But that's because they know what they're doing. You don't want to
Well,
be a
yes,
new surfer.
and
going
even
out.
people knowing what they're doing can,
Yeah.
it can Mother Nature.
Yes.
Okay, so now low tide, we're more familiar with things you can do during low tide. And look at this, tide pooling, so cool. Are there any creatures in here you recognize?
Yes. Sea anemone,
Yep, sea anemone.
sea star,
Yep, sea star.
kelp.
Yes, kelp. And what about that?
Is that a sea cucumber? Oh, it's a crab.
Yes. Yeah, that's so fun. So
I grew up, my mom taking me to when we were kids, to like the Trinidad tide pools. Like that was the thing we did.
So this is Patrick's Point.
Okay.
And it's one of those places you can go. And I've taken kids to there before and done some tide pooling. It's awesome.
And also, if you go back and you could go to the Trinidad, the sea, oh my gosh, I can't think right now, but you could do a touch tank there.
Oh yes, the Marine Lab,
Marine
Kolonica
Lab.
Marine Lab.
Yeah.
Yes, you can. It's very awesome. Yeah, to go there, you guys. It's very cool. All right, so just recently, these 2 days, January 11, 12, which was Monday, Tuesday, we had king tides. This is crazy
There's the
looking.
ellipse. There's the ellipse.
Exactly. This is crazy looking, but over where Amy is there, this is why it's so crazy. I mean, and it happens during July and it happens during January. It's that the perihelion, the closest, the sun is closest and the moon is closest. When the sun and moon are both closest, they have a greater pull.
That would make sense.
And during the new moon, they both can pull hard.
And that's, you said July and
July,
January?
yeah, and here they're in the picture, July, and then January, yeah.
Oh, okay.
So anyway, It's kind of cool. I think things are exaggerated here, but let's go and take a look at what some of the things. So this was a long time ago when we had a pulp mill, so that in the upper left corner you can see a little puff of whiteness there.
And this is the jetty, right?
The jetty, you got it. The north is on the top, and then the south is in the bottom.
See, this is where we saw it, because this is where the kids will swim sometimes.
Yes.
It's protected.
Oh, cool. Nice.
That would me pointing. But anyways.
It's all right.
But yeah.
So yeah,
That's where it was
boats come
low.
through here. This is a very dangerous, we have a very dangerous, because very narrow place for the boats to go through, but this is where boats have to go through.
I've seen people like surf, they're like up on like the surfing off of, you know what I'm talking, I don't know if it's off.
No, they surf here all the time.
Yes,
This is
yes,
a super common place for people to surf. And yeah, but this can be very dangerous. So let's take a look at some things that people were warned about, and some things happened recently. So one thing is surfing. I mean, if you're good, then that's one thing.
And people watch the tides and check on things.
And they know what they're doing, right? Yeah. So, and there are surf contests. I'm not sure we have any, but there's one down in like Santa Cruz area that's it's insane. It's called, I can't remember the name, but it's like the tides are so crazy high. So you have to really know what you're doing then. But this is an unfortunate, that's the North Jetty, and a picture of someone being helicoptered out because they fell over the edge of the jetty. And oh, look at the way the waves are. I mean, it's just plain old dangerous.
Yeah, you just don't want to go out there when it's like that.
No, you super don't. You really don't.
And they do warnings. There's warnings out there.
Warnings. It says this is dangerous. Make sure you don't go out. And here's a picture of someone trying to drive out there.
Oh,
yes.
That's where you want to park far and just look.
Look, right, because
you don't need to drive on it.
And right now, everyone, they're improving this. So if you want to go check this North Jetty out, you go on, it's called Highway 255, a new Navy base road, which means if you go over the bridge from Eureka, you take a left and you just keep driving out until you get to the very end. And then you drive and so you see this, and they're improving it. They're putting new giant boulders in and to try to keep the waves, from taking it out. But it looks like, hey, now I can really drive on it.
No.
A guy did recently drive on the beach, and his car got stuck in the water, and because this very reason, waves too high. Yeah, so it's a bad thing. This is not that place, but here's what can happen during king tides. This is Jackson Ranch Road in the Arcata Bottoms, and
it just overflows.
Yeah, it overflows, right. So it's pretty cool, though, that we do live in a place like this where we have the tides right here, because over 100 species of fish are supported in Humboldt Bay. There's giant eelgrass beds where migratory birds come in and just feed, and it's a nursery. It's just incredible.
Yay.
So yeah, it's very nice. So anyway, yay for that.
Yes. And scientific notation to help explain.
Scientific notation. Both of us using scientific notation. Woohoo! Because scientific notation, super big, super small. It helps to describe it. Yeah.
Yes, thank you for watching and tuning in.
Thank you so much, you guys. Really appreciate it.